Welcome to this course titled Designing Effective, Rigorous Student Work, as designed and produced by the Education Service Center for Region 11. In this course, you'll learn about the complexities of designing a rigorous task in which the students engage in learning and not just repeat what they've been told. In order to accomplish this task, you'll need to have clear goals and objectives that align to the rigor of the state standards, establish the criteria required to complete the task, and provide all students with the tools they need to be successful. At the conclusion of this course, you'll have an opportunity to demonstrate your understanding of the stated learning objective by participating in a demonstration lab sponsored by Region 11 Certification Team. During the demonstration lab, you'll present a 10-minute mini-lesson in which you will engage the participants in a rigorous task and assess the effectiveness of the task by comparing their work against criteria for success. You'll receive feedback based on the proficiency rubric you see on the screen. To earn credit for this course, participants must score at the proficient or master's level. For today's presentation, you'll need a copy of The First Days of School and Teaching for Rigor, a call for a critical instructional shift. You can locate the second resource on the Canvas resources for this module. So feel free to grab some refreshments, a copy of the resources, some highlighters, and let's get started. As we begin this journey of designing effective, rigorous student work, we must first examine what isn't effective. Please read pages 232 to 234 from The First Days of School. As you read, begin to reflect on what makes an effective assignment. For students to achieve success, we must artfully design the work for efficiency and maximum impact. The three components to consider when designing effective and rigorous student work are the content, the process, and ultimately the student. In other words, it's what they will learn, how they'll learn it, and what they'll need in order to learn. What the students will learn must clearly align to the lesson objective. The key is designing the task centers around the verbs in the objective. The task must meet and have the potential to exceed the level of thinking that's required to meet the objective. How they'll learn the content depends largely on the processes of communication. You must engage the students in critical reading, writing, and speaking, and you must communicate clearly what success in doing so will look like. Knowing your students will help you determine what they need in order to be successful in the task. It's important to know the abilities and disabilities of your students that impact the learning process. Let's begin with what the student is learning. The first inclination may be to open the textbook to page 1, but in order to know what the student must learn, you must start with the state standards. Your district may have documents, called curriculum guides, that will tell you which standards to teach and when, but it's the standards that drive the content. When you look at the standards, you'll notice that most student expectations start with a verb. The action verbs in a standard are an important guide to determining the level of thinking required to accomplish mastery of the standard. As we begin to develop the concept of rigor and cognitive complexity, let's look at the revised version of Bloom's taxonomy. This visual is provided by Vanderbilt University Center for Teaching and is a little different from the pages on Bloom's taxonomy in your book. It turns out that memory is the weakest function of the brain. Low-level thinking lies at the bottom of the graphic. While remembering and understanding are a part of the learning process, we want students to spend more time in class engaged in the higher levels of thinking that you see towards the top of the triangle. The graphic also does not imply an order or sequence, as some of these levels can occur simultaneously. What it does tell us is that a task that asks students to apply knowledge is also asking them to do skills related to understanding and remembering knowledge. What it doesn't mean is that I have to remember everything before I can apply it. For example, I do not have to have every addition fact memorized before I could solve a problem using addition. I do have to remember what it means to add and be able to understand and recognize an additive situation so I can apply a process to solving a problem. So the beauty is that by assigning an application level task instead of a remembering task, the application task will include understanding and remembering skills. What the brain is wired to do is make connections. It seeks relationships. When connections and relationships are formed, retention increases. Learning is more like a marathon, not a sprint. Learning centered on remembering is a sprint. It works for the moment, but is quickly lost. Learning centered on analyzing is learning that sticks because it creates pathways of connections throughout the brain. Good teaching is more a giving of the right tasks than a giving of the right answers. Many resources will list a set of verbs that are associated with each level of thinking on Bloom's taxonomy. These lists are helpful as general guidelines. However, remember that it's not just the verb, but also the context that determines the level of cognitive complexity that's required to complete the task. For example, comparing a penny to a dime is not as complex as comparing the themes and author's purpose of two nonfiction texts. Comparing a penny to a dime relies mainly on the physical features of the two coins and value, therefore may only produce remembering and understanding levels of thinking. However, the task is open to generating higher level responses such as, what can you buy with a penny or dime? When can pennies and dimes be used, etc. It also will be used to launch into deeper discussion and learning. Comparative thinking is one of our first and most natural forms of thought. Without the ability to make comparisons, to set one object or idea against another and take note of similarities and differences, much of what we call learning would quite literally be impossible. By compiling the available research on effective instruction, Marzano, Pickering, and Pollock found that strategies that engaged students in comparative thinking had the greatest effect on student achievement, leading to an average percentile gain of 45 points. When you look, Bloom's compare is generally at the analysis level of thinking. So while I am comparing, I'm also applying, understanding, and remembering. Wow! And there are a variety of strategies where the underlying thinking requires comparing. Engaging in cognitively complex tasks is not merely an end-of-unit or culminating activity. Students must begin to live in a land of cognitive complexity. Students who are presented with a complex knowledge utilization task at the end of the unit, for instance, with no question, tasks, or activities built in along the way that require them to use that level of thinking, will have much more difficulty making meaning of the task. Effective teachers incorporate short visits throughout the unit to help build the student capacity for complex tasks. Read pages 16 to 19 of Teaching for Rigor, a call for critical instructional shift. You could find this article in the Canvas resources for this module. Look at these two tasks. How are they the same and how are they different? Stop the video and think how you would compare these two tasks. Did you think of some of the similarities and differences? Both tasks have the same topic and have the same numerical solution. Creating a word problem is a high-level task, but adding a condition, like interpret this diagram, adds a whole nother dimension of complexity to the task. The yellow question is also open and has many correct solutions, whereas a blue problem only has one correct solution, although students may use different strategies to arrive at the solution. Think about your thinking. What thought processes did you go through to complete the task? Can you connect your thinking processes to the level of Bloom's taxonomy? Can you connect your thinking processes to your concept of rigor? Let's take a look at the Science Standard 4.10c. In this standard, there are 3 verbs that describe the actions a student must take to master the standard. These verbs are action words that do 2 things: tell the student what is to be accomplished, and tell the teacher what to look for. For the next part of this session, we'll focus on this lesson in progress. The students have arranged a set of cards into the progression of the life cycle of 2 plants, and have illustrated the life cycle of those plants in their science notebook. Other organisms will be addressed in another lesson. Now, the teacher is ready for the students to compare the life cycles of 2 plants. How might you assess your students on the previous objective? Read pages 259 to 262 in your book, The First Days of School, to read about planning with the end in mind. Grant Wiggins and Jay Taiji have formalized a lesson design process called backward design. Backward design contends that instead of planning the lesson around favorite activities, a more effective lesson should start with the results you want to achieve. If you don't know where you're going, how will you know how to get there? In order to gain perspective as to how a standard may be assessed, you can look at the STAR items that TEA has released. This question appeared on the 5th grade science test in 2017 and was aligned to the 3.10c TEAC, which is very similar to the 4th grade standard 4.10c. What can you learn about the level of thinking your students will need? Now that you've determined how the students will be assessed, which task will be best to prepare students for success? Well, the textbook questions may offer good questions, but if they're not focused on comparing two life cycles, then the students will not have the opportunity to engage and refine the thinking required to be successful on that assessment. Writing a paragraph describing the life cycle does not take the task to the level of thinking or cognitive complexity that's needed to master the objective. So the task that best fits the objective from this list is B. Using your illustrations from yesterday, compare and contrast the life cycle of the lima bean and the radish using a graphic organizer. Now that you've selected the task, you must be clear about what you want from the students. What are the key elements you expect to see on a successful assignment? Create a list of criteria for students so that the expectations of the task are clear. For the science task we just selected, think about what's the minimum number of similarities? Differences? What vocabulary from the earlier parts of the lesson need to be included? Do you want complete sentences? There may be many reasons to extend the lesson beyond the scope of the standard. The standard may be a STAR readiness standard. There may be other standards that connect to this standard that require a higher level of thinking. The subject area may have process standards that need to be considered in conjunction with the content that add to the cognitive complexity of the learning. You may have students that need an alternate assignment choice in order to be challenged. When you design tasks at a level beyond what is expected, the students will form more connections to the content and be more prepared to perform independently on the assignment. As teachers, one of our most difficult tasks is to balance the time allotted to teach a standard with the relevance and connectedness of the standard in order to make decisions on the level of thinking that will best serve the students. Now that you've tackled the content, you must consider the process through which they'll engage the task. The learning process requires thinking and communicating, as well as opportunities to refine and revise the thinking, so your task must have these elements. You'll find that most content areas have process standards that address these actions. The English Language Proficiency Standards, or ELPS, requires that students have opportunities to read, write, listen, and speak in the process of learning the content. Teaching is not synonymous with telling the students what you know. Teaching is connecting to what students already know and building their knowledge through interactive and engaging tasks. The more you can get students to talk about the content, the more learning they'll do. In other words, you talk less and get them to talk more. Designing a task in which students learn by engaging in it is the art of teaching. How will you get your students to ask the questions instead of you asking the questions? When you do talk, how can you ask questions that probe their thinking instead of telling them what to think? Let's go back to our science objective. We want to get students thinking, so we'll ask them to start listing similarities and differences that they notice from their illustrations, which are recorded in their science notebook. Model at least one similarity and one difference for them. Be clear about what the criteria is for completing this portion of the task. The criteria for success at this time is to have at least 2 similarities and 2 differences. Later in the task, we can add additional criteria as the level of thinking evolves. Now, students need a chance to communicate on the work they've started by collaborating with a peer. Through conversation, they may receive feedback on their ideas. consider new ideas, extend their own ideas, or possibly raise questions of their own about the task. In a class where the teacher is telling the students what to write, the students are passive listeners. But with this activity, they're listening, speaking, and most importantly, thinking. Depending on the time, you may consider doing a second pairing of students. Now they've received input from essentially 3 other students. Carefully select students to share with whole class the one key idea from their paper. In order to do this, you must be carefully monitoring their discussions and listening for students who have mentioned an essential understanding of the learning. This instructional strategy allows students to open themselves to different perspectives and approaches to the same task. After this opportunity to communicate and clarify ideas, upgrade the success criterion and ask the students to revise their work by adding new information and correcting any errors or misconceptions. Once students have had a chance to think more deeply about the task, you can raise the criteria for success. For example, make sure you've included photosynthesis and germination on your organizer, or now you should have at least 5 similarities on your organizer. Stop the video and take a minute to reflect on why it's important for students to communicate about the content. Now that you have the basics on how to design an effective, rigorous task, let's dive a little deeper into implementing the task into the classroom. As you design a task for your students, you've probably already considered the needs of most of them. Breaking the task into small chunks, using a graphic organizer, or having a word wall, these are all helpful for students. However, some students may have more specific needs, such as students with learning disabilities or students with physical challenges, students who are intellectually advanced in their thinking. These students may need a more individualized approach to the learning goal. Intellectually advanced students may need a parallel activity that accomplishes the same objective but at a deeper level of thinking. Remember this objective from earlier in the session? You may want to offer this assignment as an alternative choice for your students. In order to be equitable, offer the alternative task to all your students. You don't want to limit students' choices based on our perception of their capabilities. Offer the task as an alternative instead of in addition to the previous task, so that you're not expecting one student to do double the work. You want them to do more challenging work, not more work. Opportunities for students to make instructional decisions allow students to feel more control of their own learning. When they select a task, they're more likely to feel ownership over their learning. You design the tasks so that each choice still meets the objective. Consider these 2 tasks. In order to create a new plant, they'll have to compare their plant to existing plants. Learning difficulties take on many forms. In designing a task, you must plan for every student to have the opportunity to engage. English language learners lack access to the language to convey their thinking, so they'll need language supports. Students with impaired vision lack access to copy or print materials, so they'll need specialized tools to record their responses as well. Sometimes the difficulty may be perceived as a lack of will, when actually it's a lack of skill that prevents the student from engaging in the task. However, don't let the support you give a student take away the thinking from them. Use questions that probe the student's knowledge and skill level. Then decide on the best course of action to take to support the student's learning. Asking a question that probes does not relieve the student from the responsibility of thinking and can get to the root cause of the confusion or difficulty much faster. So, instead of the teacher telling the student what to do and taking the thinking away from the student, the teacher is listening to the student's thinking and supporting them exactly at the point of their confusion or misconception. Which of the following would help a student who has dysgraphia, or an inability to write coherently? Trick question is actually all of them. In order for a student with this learning disability to complete the learning task, we must relieve the brain of the arduous effort it takes to write in order that it may focus on the new learning. If all the student's cognitive energies are channeled into the excruciating process of creating letters on the paper, it cannot focus on the product. After the task, it's wise to summarize and/or generalize the learning and reflect back on the objective. Let's review our objective. What were some of the main points that targeted the objective? How would you summarize the key elements of designing student work? Pause the video to reflect a few minutes before continuing to the next slide. The most important takeaways from this session are: in order to design an effective, rigorous task, you must have the students take action with the content at or above the level of complexity required by the standards. You must also engage the students in thinking and communicating about ideas with opportunities to revise and refine their thinking. Finally, you must meet the students' educational needs in a way that still allows the students to be successful in thinking and reasoning about the content. Now that you've learned the attributes of an effective, rigorous task, let's review the proficiency rubric one more time. During the demonstration lab, you'll present a 10-minute mini lesson in which you will engage the participants in a rigorous task and assess the effectiveness of the task by comparing their work against the criteria for success. One final thought: engaging students in one rigorous, interactive task that's focused on the objective is more effective than answering 10 questions from the textbook. Here are some helpful tips as you prepare for your mini lesson. Spend up to the first 2 minutes introducing the objective and briefly drawing on the prior knowledge and experience of the learners. Refer to Bloom's revised taxonomy for ideas that promote higher levels of thinking. Engage your students in an effective, rigorous task that targets the learning objective. Concisely explain, perhaps model, the task and the criterion for success. While students are working, don't forget to set the timer and walk around the room to check for understanding. Pre-plan probing questions and additional resources that may be needed in order to assist students with learning deficits. Pause for a few minutes to check for understanding. During this time, students might discuss what they're learning with a peer and have an opportunity to revise or refine their ideas. Following that, you'll close a lesson. The closure is the time when you wrap up a lesson plan and help students organize the information in a meaningful context in their minds. What was an important idea that came out of the learning today? Or what do you still have questions about? Are questions that could keep the interaction of the lesson going. This helps students better understand what they've learned. Strong closure can help students better retain information beyond the immediate learning environment. Be sure to reflect back to the lesson objective. You may consider asking the participants to self-assess their progress. Today's material referenced the book The First Days of School, a monograph written by Robert Marzano and Michael Toth, and A Taxonomy for Learning, Teaching, and Assessing, a revision of Bloom's Taxonomy of Educational Objectives by Vanderbilt University Center for Teaching. And used images downloaded from Pixabay.